Okay, in today's video lecture we'll solve some more organic chemistry problems, but before that let me solve yesterday's assignment which I have given to you all. Yesterday I asked this question. This was the question: among P, Q, R and S the aromatic compounds is or are. We need to choose the aromatic compounds among these P, Q, R and S. So for this let me take a paper to solve this question. Okay, the first one is when this compound is reacted with ACl3. Okay, ACl3 is a Lewis acid, so this is an electron deficient group, so this will abstract this Cl minus ion towards itself, so we will get this intermediate. So this follows Haeckel's rule, because this carbon atom is sp2 hybridized, this is sp2 hybridized, this carbon is carbocation, so carbocations are sp2 hybridized, so this structure has follows Haeckel's rule. Haeckel's rule is 4n plus 2 pi electrons, so if we substitute this 4n plus 2, how many pi electrons here? 2, so 2, then we will get n will be equal to 0. So and here in this rule n can be 0, 1, 2, 3, something like this. Okay, so P is aromatic. Now let's come to second one. When this compound is reacted with NaH, NaH is sodium hydride, which is a very strong base. This H minus ion is a strong base. This will abstract this hydrogen from this carbon atom. This one hydrogen will be abstracted by hydride ion to form water hydrogen molecule, and Q will be this structure. This will be a structure of Q. So this is again a carbocation. So 1, 2, 3, 4. Okay, hydride ion, base, acidic. Now this carbon atom will be sp2 hybridized. This is sp2 hybridized, but the number of pi electrons here is 4. So when we substitute 4n plus 2 is equal to 4, then n is 1 by 2, which is not among these numbers, so Q is not aromatic. Okay, let us check here. For this question, ammonium carbonate dissociates to form ammonia, carbon dioxide and water, so that ammonia will attack as nucleophile to this carbon atom, like this. Let me write here. Okay, here NH3 plus, and this will be our this will be O minus, and this one is our okay. This O minus will abstract one hydrogen as base from this nitrogen atom to form this will become OH, and here one methyl is attached, and this is now NH2. This nitrogen has a lone pair of electron, so this will attack to this carbon atom intramolecularly as nucleophile like this, and we will have this like this, O minus, O minus, this methyl group, this is OH, and these two carbon atoms will be now linked by nitrogen atom, which contains two hydrogen atoms and one positive charge. Now this O minus will again abstract one hydrogen from nitrogen atom as base. These two electrons will again go to this nitrogen atom to form okay, this structure NH, one hydrogen is left, this is methyl and OH, this will become OH and one methyl is here like this will be our product. But it is said in the question that the compound formed is heated. When it is heated at this temperature, water molecule will be removed from this hydrogen atom, from this carbon atom, hydrogen atom, from this carbon atom, hydrogen atom. So these two water molecule will removed like this, and then we will get this product, double bond, and here methyl, here methyl. Okay, now this is our what, R, this is our R. Now let us check whether this is aromatic or not. This 4 electrons are pi electrons. This is a lone pair of electron. This carbon atom is sp2 hybridized. So this is methyl substituted pyrrole. Okay, so pyrrole is aromatic in nature. So our R is also aromatic in nature. Now let us check about S. When it is reacted with H plus, this lone pair of electron will go or react with hydrogen. So S will look like this. S will look like this. Okay, this will be OH. This will carry a positive charge. Here 1, 2 double bond. So this is double bond. Okay, now this will come here, and our S will look like this is 7-membered ring actually. 1, 2, 3, 4, 5, 6, 7 like this. Okay, this carbon atom will carry a positive charge. Now this will be OH, this is double bond, and this is double bond. So this is aromatic in nature, because in the ring we will have 6 electrons. Okay, when this 6 electron is substituted or equated with 4n plus 2, then n will be 1. So this is aromatic. So in the question, P is aromatic, and what about Q? Q is not aromatic, R is aromatic, and S is aromatic. So among the four options, 3 options are correct according to the question. Okay, now let us go to the question for today's lecture. The question number 1 is the maximum number of isomers for an alkene with the formula C4H8 is. Now C4H8, okay, one double bond can be here. This does not have any geometrical isomers, and another one is this one. This can have geometrical isomer. okay, because this can exist in cis transform, cis and a trans form. So 2 will come from this carbon, from this compound. 1 is here, and another, is there any possibility? I think no. So our answer is 3, that is B. Okay, second question. Anti-Markovnikov's addition of HBr is not observed in propene, but1-in, pent2-in, and but2-in. So anti-Markovnikov rule or Markovnikov's rule is applicable in those alkenes which are not symmetrical in nature. So if this is unsymmetrical alkene, so here Markovnikov or anti-Markovnikov rule will apply. But1-in, this is but1-in, this is again unsymmetrical alkene. Here also Markovnikov or anti-Markovnikov rules are applied. Pent2-in, pent2-in, okay. Is it symmetrical or unsymmetrical? This is unsymmetrical alkene, so anti-Markovnikov rule is applicable here also. But what about but2-in? See, CH3 CH double bond CH CH3. This is a symmetrical alkene, so in this alkene no anti-Markovnikov rule or Markovnikov's rule be applied. Okay, so our answer is D. Now let us go to the third question. Consider the following reaction. This is an alkane, D is deuterium, an allotrope of hydrogen, an isomer of hydrogen. Okay, now when this alkane is reacted with bromine radical, X and HBr are formed. X is the major product, and what will be the structure of X? So in the reaction of an alkane with a free radical, remember the free radical will always abstract a small group or atom. So small atom here is hydrogen only, so this radical will not abstract methyl group or deuterium, which is heavy in comparison to protium. Okay, so hydrogen will be abstracted, not deuterium. Okay, so let us check the options. So if this radical abstracts hydrogen from this carbon atom will carry a one radical will be formed in this carbon atom, which is primary radical. Okay, now from this carbon atom, if hydrogen is abstracted, then a tertiary free radical is formed. This is a tertiary free radical. Okay, now hydrogen is abstracted from this carbon atom. This is a free radical, but this is not a tertiary radical, because this is not carbon atom, this is hydrogen only. Okay, isomer of hydrogen. So this is a secondary radical. And tertiary radical, which one is more stable? Tertiary radical is more stable. So till now this is the correct option. Let us check the fourth option. So here we get here deuterium is abstracted by bromine radical, which is not in this case. Okay, so this is a secondary radical, and this is again not stable. So we will have a stable free radical is the intermediate. So our major product will be this one. B is the major product, which is the tertiary free radical. Okay, now let us go to the last question. This is an alkane, I think 1 2 3 4 2 methyl butane. When it is reacted with chlorine, n isomeric products are formed, which have a formula of C5H11Cl. Okay, when this mixture of haloalkanes undergoes fractional distillation, M is formed. M is also isomeric products. So the question here is, what will be the number of N and M? Identify N and the M. We need to select from these numbers. Okay, for this again I need to take one page. Okay, let us do in this page only. Okay, it is not clear. Okay, now chlorine can be substituted to this carbon atom, this and these are same, to this carbon atom, and this carbon atom. 4 possibilities are there. So let me write all the 4 products. CH3, CH2, here one chlorine is attached. This will be one product, and another from this carbon atom. Chlorine will be substituted to this carbon atom, tertiary carbon atom. Okay, so okay, the second compound is CH3. Here chlorine will be attached. This is methyl group. This is the product. The third one is substitution of chlorine to this carbon atom, which is secondary carbon atom, and that is CH3 like this. Here chlorine will be attached and the methyl group is attached. Okay, and the fourth possibility is to this carbon atom. So fourth one is CH3 like this, Cl. Now what we need to check here is there any chiral carbon atom? Okay, is this carbon atom chiral? Yes, because ethyl, methyl and the chloromethyl there, and one hydrogen is there, so this is chiral. So D and L, so 2 products will be here. Okay, let us check here. This is not chiral carbon atom because 2 methyl groups are attached here, so this only one product will be coming out from here. Here 2, here 1, since this carbon or molecule is not chiral. Let us check chirality of this carbon atom. There is one hydrogen atom to this carbon atom, so hydrogen, methyl and chlorine and isopropyl. This carbon atom is chiral. This is chiral. Here this was chiral. Okay, so this is chiral, so it will have its D and L form. So from this carbon atom, from this compound, we'll get 2 isomeric haloalkanes. Let us check the chirality of this carbon atom. This is not chiral because 2 hydrogen atoms are attached. This is not chiral. This is not chiral. Not chiral. This is also not chiral because 2 hydrogen atoms are attached. So it will not have any enantiomer. Actually, D and L are enantiomers. So from here 1. So this will be our N. This will be our N. N is 2 plus 1 plus 2 plus 1, that is 6. N is 6. Now what about this M? For M we need to check because fractional distillation is undergone. When fractional distillation is undergone, we cannot separate the enantiomers. So these 2 cannot be separated. So these 2 will come out as 1. Okay, these 2 enantiomers D and the L will come out as one product when fractional distillation is undergone, because in fractional distillation we cannot identify or we cannot separate the enantiomers. Okay, for separating 2 enantiomers we need some chemical methods, not physical methods. Fractional distillation is one of the physical methods. So from here, about for M, only 1 will come from this, 1 plus from here also only 1 will come, this will come. So M is nothing but 4. So N is 6, M is 4. Our answer is A. Okay, thank you for today. Please suggest in the comment section if you have any topics you want me to make a video on that particular topic. Please suggest on the comment section. Thank you for today.